Hi, everyone. We're here to talk about AI from your data lake using Solr for analytics. I'm Marceline Saunders. I'm the Director of Global Partner Enablement at Lucidworks. I've been working with different search engines for over 20 years. At Lucidworks, I manage the technical relationship with our partners, and that includes OEMs, SIs, resellers, and of course, Hortonworks is one of our main partners. I'll let Cassandra introduce herself.
Hi, I'm Cassandra Target. I am a Lucene Solr committer. I'm a member of the PMC. At Lucidworks, I'm a director of engineering. My focus is managing the Solr team, our team of Solr committers, and also managing development of HDP Search, which we'll talk about in a little bit.
Okay, now just a little bit about who Lucidworks is. We're the primary sponsor for the Apache Solr project. We employ over 40% of the Solr committers, and we contribute back over 7% of the Solr open source code. We're headquartered in San Francisco, which is where I'm located. Cassandra's out of Florida. Our employees are worldwide. We have offices in Bangalore, India, UK. We have over 400 customers in the Fortune 1000. These customers, some of them we provide Solr support and consulting. For others, they've licensed our Lucidworks Fusion platform, where they can actually build different solutions, including e-commerce, enterprise search, self-service customer support, and of course, many of them are getting into Customer 360 and analytics, and we'll be talking a little bit more about that today. The other thing, too, is that we always have, this is just a little ad for our conference called Activate. We've always had a conference called Revolution, which was focused on Lucene and Solr. This year, we've changed the name to Activate because we're also going to be doing a lot about artificial intelligence with search engines. And it's in Montreal, Canada, in October. So this Friday is the last day to submit papers. So if you're interested in submitting a paper, then you get a free pass to the conference. So it's kind of worth it. Okay, so now I'll pass it over to Cassandra.
Great, thanks, Marceline. So I'm going to talk a little bit about when we designed this, we were assuming that probably most people in the room didn't know a lot about Solr or Lucidworks or HDP Search. So I'm going to start off with a little bit of just kind of a high-level overview of that. So Solr is, the most popular search engine available today. It is built on Lucene. Actually, they share the same project. It's open source. They're both. It's an Apache project, Apache Lucene and Solr. It's scalable and distributed, so a search index is split across multiple nodes and can be easily more nodes can be easily added. It has a lot of flexibility in configuration, so pretty much everything that you need to do and the different data types you may have available to you, you can do. And if its out-of-the-box options are not satisfactory, it's also incredibly extensible. There is a Java client available for querying, but also it's easy to add, extend the base classes into new features. Just in terms of search engine features, I could do the rest of the presentation about what Solr is, so I thought I'd just focus for a second on just what the search engine features are. There's an administrative UI that you can interact with to manage the system. There's also, it supports faceting, highlighting, hit highlighting, supports multiple languages, some directly out of the box and some with additional plugins that are included with the package, just a little extra configuration. Supports spell check, autocomplete, and then what I'm going to talk a little bit more about today is some additional features that are geared around, some advanced functionality. So HDP Search is a package that is developed by Lucidworks that includes Apache Solr. And it's an add-on package for HDP, so it installs into the HDP cluster environment, has Apache Solr inside of it, and this is a distribution that's officially available from the project. So this isn't something that Lucidworks made up in any way. It is an exact actual from the project, exact package. It includes connectors for HDFS, Hive, and pig functions. We've developed a Embari MPAC, actually, so you can add that into the Embari environment to manage Solr. Includes Banana, which is open source, a port of Kibana, which Marceline will show in a little bit. And then actually documentation is online and also included in the packaging. So I said it's developed by Lucidworks, actually built and distributed by Hortonworks. So it's actually part of a partnership that we have with them. And we time our releases with the Hortonworks HDP releases. So we kind of, so far we've been pretty much tied to that schedule, and we're going to be able to kind of separate that a little bit to start getting more packages of HDP Search out separate from the HDP release cycle. So just as a little bit of a graphical kind of overview of kind of what we're talking about here is, if your data's in Hadoop and HDFS and Hive, maybe it's in some other formats and you can write some pig functions. There's ability to get that into Solr with Embari. That's not the Embari interface. It's a generic Embari picture, but another thing that actually is part of the package I did not mention on their slide, we do actually include a Spark and Solr development kit. So you can create sort of some classes that you can use to create a Spark application that can index content into Solr. So that's also included there too. There is previous versions actually also included an HBase connector. It is out of date and needs to be redesigned. So we'll be working with that at some point in the future. So we start talking a little bit about artificial intelligence features in Solr. So by itself, Solr is a search engine, but we've started to add a number of different features around allowing you to do various artificial machine learning functionality. The first is streaming expressions. So this is kind of a generic name for a group of features, which include, a math programming syntax. You can train regression models, classify results of a search, do some parallel processing for advanced functions, graph traversal with your data, what we call parallel SQL, and I'll get a little bit more into the details here. There's additionally learning to rank integration and then an analytics component. All of this, of course, these work on the data inside Solr. So, we're kind of skip over the whole part of the process of getting your data from wherever it lives into Solr, which could be another whole presentation by itself. So let's start off with streaming expressions. First, it's a stream processing language for Solr. So it's a suite of functions, essentially, to query, transform, and aggregate your data. The functions can be nested to perform multiple tasks, in one request. So you can do, so in our little screenshot here, this is of the Solr admin UI, we have we're doing a query, and then we're going to take the results of that query and do a hash join. One factor here that's pretty interesting is that if you have any experience with Solr, you know that often when you do a query, you get only a small set of results back. Streaming expressions actually work on the entire data set. And so when we say it's a stream processing language, if you just did a simple search, you would get back all of the documents that match your query in the entire database in one stream of tuples. So it makes it pretty powerful to do a lot of different things on your entire data set without trying to get like 10 results at a time or maybe 100 results. And that's actually through functionality that we call an export handler that allows you to export all results. And this functionality allows you to make do various queries. Give me all the records that have certain terms in the title or certain values in any kind of field, and then perform some functions over those with the data set in its entirety. So what are some things you can do with it? You can do some request and response stream processing. There's aggregations, parallel relational algebra with distributed joins and intersections. There's a publish and subscribe messaging. Graph traversal we've already mentioned. We can train models, and actually use those models in other functions. Ranks, there's some rank services, anomaly detection, text classification, streaming natural language processing, and then actually you can build your own too. So the classes are extensible, and you can build your own and bring that into it. So. There's three kind of ways that streaming expressions work. First of all, we talk about stream sources, stream decorators, and stream evaluators. The first is stream sources, and these originate streams of tuples. So, for example, you make a request, and the output is a stream of tuples. The most obvious being a search, right? Search for words in a title. There's another one for JDBC, which will allow you to pull in data using a JDBC driver from another database and bring that in and then work with all that data together. K nearest neighbor of a document, so you can give it a document ID and then it returns back the nearest neighbors in the system, and you can pair that with a query as well. There's another one actually called Topic, which is a publish and PubSub related one, which will sort of publish one event in response. And there's a decorator, is the next set. There's a lot of those. There's a decorator called daemon. You can actually wrap, as I said, you can nest these, right? You can take a topic, streaming expression and wrap it in a daemon and have it run on a periodic basis or on a regular basis. Let's see, some other decorators, joins obviously are this. Trying to remember some other ones here. Unique values, right? Do a search and then only work with the unique values out of that. You can do an update. Actually, you can transform the results of a query and then put them back into Solr. So you can actually kind of do a quick update on a full data set there. You can, this is where you would use classification, use a model. The last set that I said is a stream evaluator, these are functions. So this is where the math comes in, right? So you can take, again, you can nest these. So you can do a query, do some math on it, and then send it back into Solr. And there's a lot of these. And this little slide says that many more. I mean, in total, there are nearly 200 different expression types. And so these are really only, each one of these slides is pretty much just a sample. These are, obviously, add, subtract, sum, but then there's also like probabilities and regressions, and some of the machine learning functions are in here. So just a few examples. I know this is probably really hard to see in the back, so I'll just kind of walk through them a little bit. Starting clockwise here. Essentially, a rapid export of all the search results. So in this first one here, we're actually just doing a query, a *:* means in Solr get all the results. And we're just getting, a few fields back. So we're just going to get everything that, everything that's in the index for these few fields and sort it by the fields that we choose to sort by. We can do distributed joins. So we can, as you can see, we've nested these a little bit here. Let's see. Then I actually cut some from my notes. Then we can, and actually here's an example of pulling results from an external database. So actually we've got, we've started with JDBC. This is a stream source. We said the connection address, our a SQL statement, how we want to sort it, and the driver we're going to use. And that will actually pull results in. And then we can train a logistic regression model, define our features, which can be fields that are in the index already, and then use that model to classify search results based on that model. And then finally, we actually have one that's a parallel batch processing. This is very interesting and not very well explored, actually. A feature of this which allows you to actually do some really advanced and complex things on your entire data set, but using a separate collection, a separate kind of index from your main index. So you can continue to serve your normal user queries while maybe you offload this job of processing onto other nodes of your cluster. So this allows you to do that. The parallel SQL feature actually is entirely kind of designed around that parallelization that I talked about, but it is really actually an SQL interface for writing streaming expressions. And Marceline's going to talk a little bit about the integration of Solr with Zeppelin, and it actually comes from this. Actually, is where it comes from. So basically SQL statements are parsed into these streaming expression syntax. So this is just a very basic one that would turn into a kind of streaming expression that's called a roll-up, right? So basically group by becomes a roll-up after I do a search. So it supports a pretty basic syntax. It does not support joins, so it's pretty select, where, order by, and there's no reason why it can't support some of the more advanced things. It's just no one has done it yet. That's part of the nature of open source. So hopefully we will get there someday. Okay, so graph traversal is another feature again with streaming expressions, and actually this allows you to do graph queries. It works across it's a breadth first traversal, supports aggregations, and you can traverse and score the nodes within the graph. So I mean, it's just some basic kind of again, it's a type of streaming expression. Find all the movies that a certain user watched. By walking through the nodes. All movies that viewers of a specific movie watched. Pretty straightforward there too. There's lots of use cases obviously for this, for graph traversal. Find all the anomaly detection recommenders. This is exactly how recommendation engines work. Social network analysis. Find all the tweets by mentioning a certain word by me or people I follow. That's not easy to do in a traditional information retrieval environment. Find the 3-star hotels in New York City my friends stayed in last year, things like that. So that's one of the powerful features of this. So that's a little bit about streaming expressions. There's a lot more. Again, actually, Marceline mentioned the annual conference we have, and every year there have been at least 2+ presentations on latest developments and how people are using streaming expressions. So absolutely, if you just kind of do a Google search, you'll find some of those presentations. And we don't have time for me to dive any deeper than that. Because I want to also talk about something else, which is learning to rank. This is where you can rank your results based on trained models. In this case, this is actually a different functionality. Traditional relevance ranking and information retrieval uses algorithms, that kind of do a calculation of the query terms when related to the terms in the document. So TF, IDF, and even BM25 is a variation of TF, IDF. So learning to rank allows you to rank your results, according to trained models. So what is our goal here is, really just using other criteria. So you could include, base some of your relevance judgments on clicks, how often, in response to a query, these results were clicked on. Those should get a higher score. Maybe historical sales, maybe previously viewed documents, maybe the time spent on pages. Or perhaps you are in an industry where it's worth your time to actually have human judgment, to actually decide, and the expense of actually having a human being make some of the decisions about what specific documents or products are the most relevant, and use those to train the models. The training actually is done outside of Solr. So whatever tools are normally used for the training part of it. But once the model has been trained, you can upload it into Solr and then use it actually as one of the criteria of the query. So you say, here's the query, and I want it actually ranked according to this model. What was I going to say? Oh, the other thing that actually learning to rank can help you with is identification of features, and that would feed into the model if you want that data to come out of Solr. So it's kind of two sort of it helps you prepare for training the model, and then helps you use the model. Another aspect, and this one has a little bit of overlap with the streaming expressions in the sense that this is calculations and statistical aggregations. This is this is also actually kind of a bit of a plug-in to Solr. It's included with Solr, but you need to do a little extra configuration to get it set up. Both actually learning to rank but the streaming expressions, the first thing I talked about, are completely available, everything out of the box with no additional setup. The analytics component actually has three I don't want to say components, parts to it. One is expressions, which are the calculations you want to do. So on the bottom, this is a very small subset of the ones that are available. I should have made that more clear. You could round numbers, do if, greater than, divide, etc. So these are actually the calculations you want to perform. And so you could just do a query and ask for these calculations and get the result. There's also a concept of functions, which are variables, basically variable expressions, where you can say, I want this expression, sort of an expression maybe you're going to run a few ways. And then groupings are essentially facets. So you could say, what I want to do is I want to get I want to query my database for records that contain certain words, and then I want to divide sales, number of sales of the product by number of stores they were sold in, and then I want to group them based on the result of that, right? So I want the groupings between 1 and 5 in one bucket, so I can look at those, and I want between 5 and 10 in another bucket. So these three things can kind of work together. And this is a bit more the traditional sort of query, calculate, present model with facets. The streaming expressions really give you like a flow of data that you can work with. I was just about to say something else about the analytics. All right, I think that's I will remember it in a second, but I won't jump in. So those are kind of three areas there in Solr. So I'm going to turn it over to Marceline and let her talk a little bit more about the tools that one might use for this.
Right. So now that we've gone over some of these advanced features that are in Solr, now we can talk about the different tools that are available. Some are open source, some are not, but they both work with both Solr and our own product called Lucidworks Fusion, and I'll be talking about both of these. So the motivation for Lucidworks to provide tools or integrate with tools is we have a lot of customers, just like many of you, who have data lakes. They have petabytes and petabytes of data, and they really want to get insight from their data. And they want to have self-service exploration of data. So that means providing tools for analysts or for data scientists where they don't have to know a specific query language, or they just be able to create views for the different users as well. So that is really the motivation that we have. We talked a little bit about Solr SQL, and really why is this push for SQL? Well, SQL, it's a known query language. I mean, almost everybody knows it or knows the basics of it. It eliminates retraining for users if they already know SQL. And the big push really is because if you have a SQL or a JDBC driver, you can leverage third-party BI tools. Almost every third-party BI tool will support JDBC or SQL, and that's sort of really the focus, and I'll dive into that a little bit more. And also, with some of the tools, it allows you to join your Solr collections easily, or join your Solr collection with other data sources that you may not have indexed with Solr. So there's a lot of possibilities with many of these tools. So the ones I'm going to talk about Cassandra talked about Banana, and I'll talk about that because it does come, it's available with HDP Search. I'll touch on Zeppelin. I'll be talking about Zeppelin that works with Solr 6.0. And then Lucidworks Fusion, which is our product that's powered by both Solr and Spark. I'll go over into the details, but Tableau works with it, Zeppelin works with it. Actually, any third party that supports JDBC will work with Lucidworks Fusion. And finally, I'll just touch on a product that ships at Insights is part of the Fusion platform, and I'll just touch on that. So Banana Dashboards, as we said, is a porta cabana. It's very easy to create dashboards for a Solr collection. This is just an example of your query logs. Just index the query logs, and then you can see all this information easily. It's a very easy product to use. And it doesn't have to be just logs. It can be any Solr collection. And in this example, this Solr collection had information on city banks in New York City. So we have latitude and longitude, and we can visualize that information. We have gender. We can do all kinds of stats as well within this tool. So every little box, one of those boxes, we can do averages, we can do probability. There's all different types of calculations you can do within the Banana dashboard. So that's all part of HDP Search. It is open source, and it can be, if you don't have HDP Search, you can just download it as well. As we were talking about Zeppelin, so Solr, so Solr has SQL, and because of that, we can definitely integrate with Zeppelin. And the great thing is we actually, all you have to do is create a Solr SQL interpreter within Zeppelin, then you can connect to your Solr collections. And it's probably hard to see the SQL in there, but in every box there's some basic SQL mixed in with some Solr syntax. So if you see the underscore query underscore, then it's, that's, you can put any kind of Solr query in there in each box as well to visualize your information. So just a little bit about what Lucidworks Fusion is. So as I said, it's powered by Solr and Spark. If you use Fusion, if you have an existing Solr cluster, you can point Fusion to that existing Solr cluster and start using Fusion with that cluster, as long as the Solr cluster is 4.10 and above. Just so you know, we're at Solr 7.3 today. The great thing with Fusion, it comes with over 40 out-of-the-box connectors. So you can connect to SharePoint, Jive, different file systems. So it's really a pull model. You can go out to any system within your organization and index that data. Gives you more access to information. On the extreme right-hand side of this diagram, we're talking about insights. We provide machine learning algorithms and models. That's really where Spark comes in. And to be able to do dynamic clustering of data, it's just an easier way to do these things. The reason why I want to bring up Fusion is really, in this diagram, you'll see how Fusion works with Tableau. So because Apache Spark is part of our Fusion platform, Tableau easily connects to Spark SQL. So we connect to Spark SQL. Information from Tableau will then now go down to Spark SQL. If there's any Solr queries within that you want to add in there, it will get sent down to Solr. Spark SQL will decide if it needs to talk to Solr and get information back from Solr, and then it'll start doing the hard work that Spark is great at doing. So just a little bit about Tableau. It shouldn't be a Tableau commercial, but Tableau is a pretty easy product to use. So you just have to connect to Spark SQL within Fusion, and then it looks at all the collections. These are just all the different collections that I have in one of my clusters. And each collection looks like a database to Tableau. It's, okay, that's a database. Then you'll notice in the center it says drag tables here. And that's what you do. You actually pick up a table and drag it. And you can pick up multiple tables, and you can do joins. It's a very easy way to do joins across Solr collections. And it's very easy for your analysts or for your data scientists or whoever is working with this data that understands the data. So because they understand it, this makes it easier for them to access that information, which is really important. And again, Tableau out of the box comes with, you have this data, maybe you have some long information, you have some geographic, you can easily, very simply, create different visualizations. This is just another example where on the extreme right-hand side, you can see all the different types of visualizations. You just have to click a button and you have a new one, and then you just save that workspace. If you want to keep that workspace, and then also you can actually extract that workspace and share it with other people within your organizations, which is very useful as well. Okay, so we've been talking about tools, like this is why SQL is, why we are focused on it at Lucidworks, to work with these third-party tools, and also just to make it easy to work with your data and do joins across all that data. And then finally, I just want to talk a little bit about Fusion App Insights. This is a tool that comes with our Fusion platform. Out of the box, it comes with 30 different types of reports that can go against your Solr collections or against your logs. In this case, it's the logs that we're looking at, but also within Fusion, you can actually capture events that users, if you have a enterprise search solution and users are clicking on different documents, we can actually capture those events, and then you'll see those events within the Fusion App Insights product as well. And this is just another example. These are just out-of-the-box visualizations of your data. In this case, it's from our logs. Okay, so this is just some of the resources that we have. If you're interested in being able to use Zeppelin with Solr, what?
I remember what I was going to say.
Oh, okay.
The analytics component that I mentioned is actually developed by Bloomberg, and they wrote a blog post about it. So
yeah.
if you were interested in knowing a little bit more about why they did it and how they use it, there's a link here that it's at tech at Bloomberg. And
That's right. Yeah.
Sorry.
Yeah, so we actually have instructions on how to set up Zeppelin with Solr, instructions of using Tableau with Fusion if you're interested. And we actually have it with Jupyter as well and some other tools, so not just those two tools, but we have a number of tools that work with Solr. But okay, any questions? You went pretty fast. Yes?
Yeah, so about the external data sources, what you mentioned that you can pull the data using the JDBC driver. So when you say pull the data, so does that come into the collection and create a copy into Indexer?
So the question is, I talked about external data sources, and he wanted to know, does the data have to come into the collection, or can it stay outside? Actually, you could do either or. We have customers who, there's features in Solr. You could actually do either or. Yeah, so I just didn't show that, but definitely you could do that. We have customers who want to go against a relational data. It's very common you want to go against a relational database, but you don't want to index the relational database. You might want to just do some lookups, and that's a common use case, actually.
Nope, that's true. Yep.
But you still be able to do like hash join and all those things. If I'm not
Yeah.
wrong.
What's the question? Do what?
Hash join?
Oh, hash join.
Oh, I'm sorry. You'd still be able to do a hash join, was
Yeah.
the question. Yes.
Got to
Yeah.
repeat the question.
Sorry.
Yes?
We use deploy Solr on a Hadoop like HDP data platform.
Okay, the question is, can you deploy Solr on a Hadoop? Oh,
When,
Deploy Solr in a Hadoop cluster. When we create the indices, should they be on the local file system or on the Hadoop file system?
so,
repeat the question.
yes, so the question is, when you deploy Solr in a Hadoop file system, should the indexes be in the Hadoop file system or on the local file system? So I don't have the concrete answer for you. And some people find that they don't like the performance of the indexes. Some of it has to do with how much indexing you're doing, how much new data you're adding. Because if you put them in HDFS, they're getting, Solr has its own replication that it does between nodes. And then additionally, HDFS has its replication. So you've got a lot going on, and people have noticed performance suffers in that case. Queries should be better. So if you kind of have a semi-static set of data and you get it into Solr and you're not going to touch it very much, your indexes in HDFS are probably fine and give you some good like replication and failover using HDFS. But if you're constantly re-indexing data, you're going to have a lot of activity happening, in which case, you know, you may not like the performance. Some people have complained, some people are fine. It kind of depends. You have, you know, we kind of always say this, a little bit of experimentation goes a long way. Okay, go ahead.
Will Solr support storing on the local file system the indexes through several disks?
Does Solr support storing the indexes on the local file system across multiple disks?
Yes, on the same machine.
On the same machine? I am not. Oh,
What does he want to do?
so what?
What was the question?
The question is, does Solr support storing indexes in a local file system, but on multiple disks on the same machine?
We'll go across disks.
Yeah, I'm actually not sure. I have to honestly say I'm not totally positive. I'm sorry, in the back.
You said that newer releases for HDP Search and passive releases will be tighter, like, because right now it's 6.6, whereas Solr 7.3, you said? So you're going to have more frequent updates.
Right, so the question is about the frequency of updates of HDP Search, the MPACs. So traditionally we have, by request actually, been completely tied to the HDP release cycle. With changes that Hortonworks is doing to the MPAC system, they are sort of decoupling the various MPACs from the HDP releases. So we should be able to do more frequent releases of HDP Search in order to upgrade Solr, you know, the Solr version as we go along. I know HDP Search was kind of stuck on Solr 5 for a long time. That actually had nothing to do with MPACs at all, just so you know. Like, it was entirely by request. We would upgrade it a long time ago.
Yes?
Okay.
Just because I want to hear my voice.
All right.
Maybe I won't. Oh, there we go.
There you go.
So the question is do you see speed up in the ML algorithms on Solr versus, like, say, inside of MLlib with Spark or something, those other options you have? And also, can you do CNNs and deep learning inside of Solr? CNN, RNN, those kinds of algorithms. I didn't see them up there.
I don't know that you can do. So the second half of the question with the CNNs and RNNs, I'm not sure if you can. I don't think you can. I think they're still pending. I think they're coming. In terms of speed up, I don't know any specific performance data, but if I had to guess, I would say Spark is probably faster.
Actually, that's why we use Spark and Lucidworks Fusion, because it is a lot faster. So we're using Spark for all the machine learning algorithms, and also in Fusion you can write your own with Scala. You can write any models that you want and load them up in.
Sorry, just
Yeah, go ahead.
y'all can leave. I just got a carry-on question. I can talk to them afterwards too. But
Okay.
We're trying to set up something comparable to this. But what we want to be able to do is utilize the data that's inside of our document store that already is stored inside of Solr. But we want to be able to do some type of, like, NLP against it. Obviously, you can do that inside of Solr. But then also after that, do some type of clustering algorithm that allows us to do tipping and recognition of new documents that come in that are comparable to other clusters that we've already established. And so the idea is how do we go about doing something like that, particularly if we've already had our data spread out across either HBase or inside of your collection set, which is obviously, or more than likely not on HDFS, is inside the collection itself. Is it that we need to port the data out? Do we need to get it out of Solr? Should we do it inside with the NLP that exists inside there? If it is faster to do with EML, can we actually reach into Solr's collections to do with Spark to pull it out and actually do the ML against it? Or are we kind of just like, do we need to do a replication of our whole data set?
So I'm not sure how to answer the full entirety of the
I
question.
can keep on talking too.
Yeah,
if you
no.
want.
But I will say, I mean, I think it is possible to use Spark to pull in, to get data out of, to kind of go into Solr, and then we have a Spark Solr integration piece. So that part, you know, I definitely know, you know, should be possible to kind of try to do. As for architecting the rest of the solution there, I'm not sure. I mean, it's you know, I'm not sure. I don't know.
I can probably, if you give me your card, I can send you some information
Yeah.
on how to do that. Because yeah, with the Spark, if you don't have to use Lucidworks Fusion, but if you want to just do Spark and Solr, you can do that. In Spark, you can actually reach into Solr, pull information out, I would do the clustering through through Spark, and then you can write it back into Solr. So there's actually ways to do that. I have some Scala code that can do that. So
Okay.
yeah,
Cool.
So I can share that.
Okay, that's it. I think.
Okay.
Thank you, everybody. Thanks.
Thanks.